Firewalls. A firewall is a security system that examines each packet passing through it. If the firewall identifies the packet as an attack packet, the firewall discards it and copies information about the discarded packet into a log file. A firewall acts as a barrier between a trusted network and an untrusted network. A firewall controls access to the resources of a network through a positive control model. This means that the only traffic allowed onto the network is defined in the firewall policy. All other traffic is denied. The term firewall comes from the actual fireproof walls that are often used in real buildings to form a barrier across which fire cannot spread. Network firewalls provide comparable protection to a set of network computers. The firewall partitions a set of machines into two groups and forms a barrier that protects one group from danger in the other group. Most commonly, a firewall is used by an organization that connects to the global internet to partition machines into those inside the organization and those outside the organization. The role of a firewall is to prevent malicious traffic reaching the resources that it is protecting. Some security experts feel this is an outdated approach to keeping information and the resources it resides on safe. They argue that while firewalls still have a role to play, modern networks have so many entry points and different types of users that strong access control and security at the host is a better technology approach to network security. Firewalls were officially concocted in mid 1990s. However, the idea truly mirrors the reference monitor. In operating systems architecture, a reference monitor idea characterizes an arrangement of design requirements on a reference validation mechanism, which authorizes an access control policy over subjects, capacity to perform activities on object, such as read and compose on documents and attachment on a framework. The properties of a reference monitor are called by the acronym NEAT, which implies the reference validation mechanism must be non-sidestep capable, with the goal that an attacker can sidestep the system and violate the security arrangement. The reference validation mechanism must be evaluable, that is, amenable to examination and tests, the completeness of which can be guaranteed. Without the property, the component may be imperfect such that the security policy isn't upheld. The reference validation mechanism must be constantly conjured. Without this property, it is feasible that for the instrument to not perform when expected, enabling an attacker to damage the security policy. The reference validation mechanism must be carefully designed. Without this property, an attacker can undermine the component itself and then violate the security policy. A firewall is a very special type of reference monitor. After very carefully situating a firewall inside a network system, we can guarantee that all the network accesses that we need to control must go through the firewall. This restriction meets the always invoked condition. A firewall is normally very much isolated, making it exceedingly insusceptible to medication. Normally, a firewall is actualized on a different computer with direct connection just to the outside and inside network system. This disconnection is expected to meet the tamper-proof requirement. Firewall developer empathetically suggest keeping the usefulness of the firewall straightforward. Individual in the firewall group, that is user, designers, developer, or security specialist, they don't agree about how a firewall should function. Specifically, the group is divided about a firewall's default conduct. The two school of thought can be depicted as that which isn't explicitly illegal is allowed, and that which isn't explicitly allowed is taboo. Clients who are constantly inspired by new highlights incline toward the previous. Security specialists relying on a very long while of experience strongly consult the latter. An administrator or configuring a firewall must pick one of the two methodologies, in spite of the fact that the administrator can widen the policy by setting the firewall's parameter. At the point when organizations started moving from centralized server PC and dumb client to the client server model, the capacity to control access to the server turned into a need. Before firewall came the main genuine type of network system, security was performed by access control lists living on the routers. Access control lists figure out which IP address were allowed or denied access to the network system. The development of the internet and the subsequent expanded connectivity of networks implied that this kind of filtering was not any sufficiently more to keep out malicious activities, as the essential data information about network traffic is contained in the packet headers. Digital Equipment Corporation delivered the first firewall that was used commercially, and firewall technology has since developed to combat the expanding refinement of cyber attacks. Firewall have an extensive variety of capabilities. Different types of firewall incorporate screening routers or packet, filtering gateways, stateful examination firewalls, application proxies, personal and guard firewalls. Each type does diverse things. No one is fundamentally right and other wrong. Generally, screening routers tend to actualize rather oversimplified security arrangements, while guards and proxy gateway have a wealthier arrangement of decisions for security policy. Simplicity in a security proxy gateway Simplicity in a security strategy isn't a terrible thing. The important thing to ask while picking a type of firewall is a thing that dangers and installation needs to counter. Since a firewall is a type of host, it is frequently as programmable as a decent quality workstation. While a screening router can be important, the inclination is to have even router on entire computer with operating system, because editors and other programming devices can help configuring and keeping up the router. On the other hand, firewall designers are minimalist. They put effort to take out from the firewall all that isn't entirely fundamental for the firewall's usefulness. There is a justifiable purpose behind this negligible requirement to give as little help as possible to a successful attacker. In this way, firewalls tend not to have client accounts so that, for instance, they have no password file to hide. To be sure, the most attractive firewall is one that runs with satisfaction in the back room, with the exception of intermittent examining of its audit logs. There is seldom reason to touch it. The most basic firewalls worked as packet filters, inspecting the packets that are exchanged between computers on the internet. At the point when a packet goes through a packet filter firewall, its destination and the source address, protocol, and destination port number are checked against the firewall's rule set. Any packets that aren't particularly permitted into the network are dropped. For instance, if firewall is configured with a rule to block telnet access, at that point the firewall will drop packets bound for TCP port number 23, the port where a telnet server application would tune in. Packet filter firewalls work primarily on the first three layers of OSI reference model, although the transport layer is used to obtain the source and destination port numbers. While generally fast and efficient, they have no ability to tell whether a packet is part of an existing stream of traffic because they treat each packet in isolation. This makes them vulnerable to spoofing attacks and also limits their ability to make more complex decisions based on what stage communication between hosts are at. With a specific end goal to recognize a packet connection state, a firewall needs to record all connections going through it to ensure it has enough data to assess whether a packet is the beginning of another connection, a piece of a current connection, or not some portion of any connection. This is called stateful packet inspection. Stateful inspection was first presented in 1994 by the Checkpoint software in its Firewall 1 software firewall. And by the late 1990s, it was a typical firewall product highlight. This extra information can be utilized to give or reject access based on the packet's history in the state table and to accelerate packet processing. That way, packets that are part of a current connection in the view of the firewall state table can be permitted through the without and coverage analysis. In the event that a packet does not match a current connection, it's assessed by the rule set for new connections. As attack against web servers turned out to be more typical, so too did the requirement for a firewall that could secure servers and the application running on them, not simplify the network assets behind them. Application layer firewall technology initially developed in 1999, empowering firewalls to investigate and filter packets on any OSI layer up to the application layer. The key advantage of application layer filtering is the capacity to square particular content, for example, non-malware or certain sites, and perceive when certain protocols and applications, for example, HTTP, FTP, and DNS are being abused. Firewall technology is currently fused into a variety of gadgets, numerous routers that pass information between systems contained in firewall components, and most home computers operating system incorporate programming based firewalls. Numerous equipment based firewalls likewise give extra usefulness, like fundamental routing to the invert system they secure. Firewall proxy servers likewise work at the firewall's application layer, going about as an intermediary for requests starting with one system, then on to next for a particular system application. A proxy firewall avoids direct connection between either side of the firewall. The two sides are compelled to lead the session through the proxy, which can block or permit traffic in light of its rule set. A proxy service must be keep running for each sort of internet application. The firewall will support, for example, a HTTP proxy for web services. Guards are sophisticated firewalls. Like a proxy firewall, a guard gets protocol information unit, blocks them, and goes through the same or distinctive protocol information unit that accomplish either a similar outcome or an altered outcome. The guard chooses what administrations to perform for the client's benefit as per its available information. For example, whatever it can dependably know about the outside client's identity, previous interaction, etc. The level of control a guard can give is restricted just by what is processable. However, guards and proxy firewalls are sufficiently comparative that the distinction between them is sometimes fuzzy. That is, usefulness can be added to a proxy firewall until the point when it begins to look a considerable measure like a guard. Individual firewalls are application programs that keep running on workstation to block undesirable activity for the most part from the network, and they keep running on every computer they are attempting to protect. An individual firewall can supplement crafted by an ordinary firewall by screening the sort of information a solitary host will acknowledge, or it can make up for the absence of a general firewall, as in private DSL or link modem connection. Similarly, as a network firewall screens incoming and outgoing movement for that network system, an individual firewall screens activity on a single workstation. A workstation could be powerless against malicious activity agents or malicious code, spillage, or individual information stored on the workstation, and vulnerabilities scan to distinguish potential shortcomings. Virtualization techniques, for example, virtual desktop framework can progressively react to various situations by offering customized access control to applications, records, web content, and email attachment in light of the user's role, device, location, and connection. This way to deal with security provides extra assurance that a firewall can't. However, data security requires safeguard from top to bottom, and firewalls still offer fundamental low level protection and also give logging and evaluating capacities. Firewalls enforce access rights and protect the system from external systems. To ensure a high level of security, the organization may array multiple firewall in a defense in depth configuration, like top to bottom, which is the use of successive lines of defense. Firewalls are high level software utilities sit on the router end of the physical network. Network security policy embedded in the firewall software dictate access. Consequently, the presence of a verified set of policies for access control is as important to information assurance as is the system engineering work that establishes and maintains them. Furthermore, firewalls have to be able to distinguish between unsolicited traffic and inbound traffic requested by an internal user. Firewall virus checkers and most IDs are reactive technologies attempting to stop dangerous input from causing a vulnerable computation. A better approach is to build a robust computation that does not require such shields. Nature of the problem is exacerbated by the difficulty of not knowing what to block and what not to block. The problem is that there is no ultimate list of input to block because each program is unique in its language. Following is a comparison of firewall types. Packet filtering is the simplest type of firewall and it sees only addresses and service protocol type. Furthermore, it makes auditing difficult. Packet filtering screens based on connection rules. Finally, complex addressing rules can make configuration tricky. Stateful inspection is more complex and see either addresses or data. Auditing is possible with stateful inspection. This firewall screens based on information across packets. In either header or data field, finally it is usually pre-configured to detect certain attack signatures. Application proxy is even more complex and sees full data portion of packets. An application proxy can audit activity and it screens based on behavior of proxies. Simple proxies can substitute for complex addressing rules. Guards are the most complex and they see full text of communications. They can audit activity and they also screen based on interpretation of message content. Complex guard functionality can limit assurance. Personal firewalls are similar to packet filtering. This firewall can see full data portion of packet and it can and usually does audit activity. Typically, the personal firewall screens based on information in a single packet using header or data. Finally, it starts in deny all inbound mode, to which a user adds trusted addresses as they appear. In summary of firewalls, firewalls are not complete solution to all computer security problems. A firewall protects only the perimeter of its environment against attack from outsiders who want to execute code or access data on the machine in the protected environment. Furthermore, firewalls can protect an environment only if the firewalls control the entire perimeter. That is, firewalls are effectively only if no unmediated connections breach the perimeter. If even one inside host connects to an outside address by modem, for example, the entire inside net is vulnerable through the modem and its host. Firewalls do not protect outside the perimeter. Data that have properly passed through the firewall are just as exposed as if there were no firewall. Firewalls are the most visible part of an installation to the outside, so they are most attractive target for attack. For this reason, several different layers of protection called defense in depth are better than relying on the strength of just a single firewall. Firewalls must be correctly configured. That configuration must be updated as the internal and external environment changes, and firewall activity reports must be reviewed periodically for evidence of attempted or successful intrusion. Firewalls are targets for penetrators. While a firewall is designed to withstand attack, it is not impenetrable. Designers intentionally keep a firewall small and simple so that even if a penetrator breaks it, the firewall does not have further tools such as compilers and linkers, loaders, and the like to continue an attack. Firewall exercise only monitor control over the content admitted to the inside, meaning that inaccurate data or malicious code can be controlled by other means inside the perimeter. Firewalls are important tools in protecting an environment connected to a network. However, the environment must be viewed as a whole. All possible exposures must be considered, and the firewall must fit into a larger, comprehensive security strategy. Firewall alone cannot secure an environment. Thank you.